Hello, my name is Kaylynn Watson. I'm a software engineer at Focus Labs. We've been doing a lot of work with AI, specifically around RAG or retrieve and generate type applications. Today I'm going to walk through automating some of that testing or debugging process. Here I have a RAG that I'm setting up. I want to make a little tool to make my life easier around creating demos and documentation to stakeholders. So I'm ingesting a bunch of PowerPoint documentation from our previous demos, and I'm hoping I will be able to use this to create more demos in the future. So this is pretty standard RAG. I'm using Python and LangChain, specifically LCEL. I ingest the files here. I have my vector database here, currently just using the Facebook one. I have my chat prompt, which is very generic, and of course my chain. But down here, what I'm quickly running into, if I run this for you, is that every time I want to test out my chatbot, I have to type in a question, something like, what is a one-word summary? Or something like that. And I would like to automate this process to make it a little bit quicker. So I'm gonna walk you through that today. I'm gonna live code it and we're gonna have a good time. All right, so let's start by moving all of this into some functions. That way we'll be able to call this from a separate function. So yeah, let's just start there. So we're gonna call this, I don't know, something like ingest PowerPoints, and we'll have all of the ingestion up to the vector database inside of that. I tend to like to separate my ingestion from my querying in my code architecture. I find it a little bit cleaner to just cut it along that line. I'll just return my vector database, and then we'll move the rest of the stuff into like a query method, and that will accept a vector database as a parameter. Let's move this into here, and then we will move this kind of logic into here out of main. There's two reasons for this. One is we want to invoke on the chain, not a copy of the chain. So that needs to happen. I can't just like pass the chain back and then invoke on it because of the way Python does copying. So, and then also I like doing it this way because it kind of keeps everything a little bit packaged together outside of my main. So we'll do something like chain.invoke. I'm not gonna do streaming here. We'll just do input, user input, adding that as a parameter. User input, that'll be a string. So now, if I want to call it, I will need to set up my vector database, and then we will query with the user inputs and the vector database passed in. And we can call this results and just print results. So this will still work. I will also make this add some helper functionality, so that way we'll be able to run multiple Python scripts from our IntelliJ a little bit easier. Alrighty, so now if I run this, it should still work. Let's ask what are the main points? None. There are no main points. Interesting. We may have run into an issue. Let's ask a different question, like, summarize this in one word. Oh, I wonder if we're printing the none type. Yeah, we need to actually return. So let's try that again. What are the main points? There we go. Alrighty. And since it's not asynchronous, it took a little bit longer, but that's totally okay. That looks like it's working. Awesome. So we'll terminate that and we'll create a new file. We'll call this accuracy tests. Let's create a new function called Factual accuracy. So here I want to have a list of questions that I call every single time. By asking the same questions, I will be able to compare kind of apples to apples as I change different configurations in my code, if the answers are actually improving or if they're not improving. There is a risk while doing this to overfit your data to your questions, so having a larger set of questions is generally better. For the central limit theorem, that's about 30. I personally like about 50, but that again depends on your use case, depends on the size of your data set. You may even want more. But it's a good place to start at about 30. For today, I'm probably only going to write a couple. So let's go ahead and just get that out of the way. So new file, we'll just call it questions.txt. We'll add it to Git. We'll start with when was the latest demo. When was the earliest demo? Summarize the demos in one sentence. Maybe I'll rephrase this to be in only one sentence. What are the main points of these demos? We'll just start with those three. So coming back, we're going to need to open this file. So we'll do just some classic Python with questions.txt. We'll read it. We'll just open it as file. It's nothing fancy. So for each line in file, we'll have a question and we'll strip all the white space from it. We'll have an array of questions that we'll append to. So questions.append question. I also like adding an if statement in here. If there's a hashtag or an octothorpe or a pound sign, depending on what generation you're from, if there is this character in front of a question line to skip it, this way I don't always have to go through the whole list of questions, especially if you have 30 to 50 questions in here and you don't want to go through them all. Adding a octothorpe in front of them can just make it easier. So if line starts with one of these characters, then we'll just continue. Alrighty, so now that we have our list of questions, we'll need to actually query. So this logic will look very similar to what we had in our other main function. So we'll have a vector database, and that'll be ingest PowerPoint, and we'll need to import this. And then we will have our results be the query, question, and the vector database. So we'll import this from main. And so now we'll need a for loop for question in questions. We will have the results. Alrighty, pretty straightforward, pretty easy, but I want to add a little bit more fluff or supporting infrastructure to this. So I like outputting and saving all of this content to CSVs. There's two reasons for this. One is you're able to manually look at all of the questions, look at all of the answers, make sure everything's looking okay, see any anomalies. The second reason why I like putting these in CSVs is then you can go through and like kind of score your accuracy and then total up the scores just like right there in the file. So I'll go ahead and I'll show you that later on, but the CSV logging gives you, I guess, track history into what you're experimenting with, and that helps break down the cognitive load of what do I test, when, and what related to, or what change related to what output. It can get really spaghetti really quickly, and so having this very set, repeatable process, similar to a scientific method, I find helps strategize your experimentation. So again, I'll walk through that a little bit more at the end. Well, let's get back to the code and then you can see what I'm talking about. So let's output this to a new file. So we'll just call it with open, I don't know, output.csv is pretty easy. We want to write new line. We'll just keep it a normal new line so we don't have to deal with any carriage returns or anything weird like that. We need to set up our writer. So we'll just do that to add our file. And then we'll have our writer. We'll first write a header. So this will have a question column, we'll have an answer column, and we'll have a score column. And then we'll do all of this with the file still open, and then we will write our question and results to the line. So if we actually run this, I actually don't like this name. I'm gonna change it to Factual Accuracy Test. Alrighty, so now if we run this, this should work. And then we have output.csv. And we have our question, answer, and our score. When was our last demo? The last demo was held last week. When was the earliest? And only one sentence. I have a CSV plugin on my IntelliJ, makes it a little easier to see. So yeah, that looks correct. Let's add a couple of other metrics or columns to this. I like adding timestamp. I like using this to gauge how quick or the latency in a app. Like if I have like 30 questions or 50 questions and I run through all of them, then I can see, oh, did it take 20 minutes? Did it take 3 minutes? Since latency is a big issue, so we'll just add timestamp. So timestamp equals, and I always forget what the certain format of timestamps are, so I'm gonna come over to ChatGPT and ask how to print a timestamp in Python. So that was pretty easy. We have a human readable format of a date time stream. We don't have to worry about epochs or epochs or anything like that. So I'll go ahead and just copy this. Remember that's datetime.now. So we'll do datetime.now. And then paste that in. We'll add timestamp to our logging, and then the other thing we should do is we should log any bugs or errors. So we'll just throw a generic try around our querying, and we'll catch any exception. So let's see, let's do results and error. So then we'll set error equal to E down here, and then we'll be able to log error every single time. I really like, so you may not always need error. I like having an error just so that way we can continue to run a bunch of questions. I know earlier on in a lot of these RAG apps, we'd run into like type conversion errors or JSON parsing errors, kind of dumb stuff like that. So you don't always want to stop your whole accuracy test running just because of a one-off, but you still want to capture those. So we have the error there, and I think we're good to run this. Alrighty, so we went ahead and overwrote our old output. We have our timestamps, we have our questions, we have our answer, any errors, and then the score. So again, going back to like what kind of format do I like to do for this? I like uploading this to Google Drive. So let me go ahead and pull up my Google Drive. All right, so now my output.csv is in my experiment data folder. You can see I've done this quite a few times before. But yeah, let's go ahead and open it. We'll just go ahead and open it with Google Sheets. Then I can format these cells to make it a little bit easier to read. And then I can go through and I can score. The scoring system that I like to use is a scale of -1 to 5. -1s are the bugs or the errors. I want to really like heavily penalize my app against any errors. Zeros are it was completely wrong or it answered I don't know when it should have known. So completely wrong. 1 to 4 are various amounts of accuracy. I add points for pieces of information it got correct, and I subtract points for pieces of information that were incorrect, or if there's like a really big gap in knowledge. The 5 score is a perfect score, and that's for it's basically correct. Again, this is only a factual type of analysis or scoring. In the future, we can do another video on a like soft or conversational type of accuracy in scoring, but right now we're just focused on factual. So the other thing to keep in mind while scoring your answers is to have an open mind. Many times you come in with a perceived correct answer, but your question might have been vague and the LLM may have interpreted that a completely different way that was completely valid, but not what you were expecting. So don't just say, oh, that's not the answer that I wanted, completely wrong. We're going off of factual answer accuracy. Again, I've said this a bunch of times and I'm rambling at this point, but just a good reminder. So let's go, like, when was the latest demo? The latest demo was Friday, November 10th, 2023. That's definitely not correct. The latest demo that was today. So the earliest demo, that might be correct. I'll need to go ahead and verify, but we're just going to assume that that's correct for the sake of this exercise. The main points of this demos are brainstorming, creating landing page, mock developing messages, building landing page, conducting market research, and build at least one demo. That sounds accurate, but you can see, again, a good use case or a good example here for why conversational type of accuracy would be a good analysis to have, because that was not in great grammatically correct sentence, but it's accurate. So then I can come in here and just say the accuracy equals the sum of all of that, and then I can say the accuracy possible is actually 5 times how many questions I have, which is 3. And so my score is this divided by this, which is a 66% correct. So you can see exactly why when you have a number or a metric, having more questions makes this much more meaningful. If I only have 3 questions every single time, then this can go from 90% to 40% when it just got one question incorrectly. So that's why I suggest having around 50 questions. But then what's really cool is you can keep track of your accuracy over time. And I do so in a Notion page. I have it set up so that I have like a hypothesis of what I think is going to improve and why. Then I make that change, run the test, and then calculate the accuracy. And I have a very tangible, very easy to explain to stakeholders, metric-based type of way of proving that what I did helped or what I did not help. So these are the basics. There are other ways that I would recommend improving this are to have more touch points along the way. The RAG apps, I kind of think of them as cakes. They cannot be truly evaluated until you go through the whole baking process. So if you add just a little bit more milk or an extra egg at the beginning of the process, you can't fully evaluate how good that cake is until you mix up the ingredients and bake it and let it cool and then frost it. So you have to go through the whole process. Every single component will affect all the other components. But that doesn't mean you can't have any like sanity checks along the way or common sense. If you have like the consistency in your batter of water, like it's probably not going to be a good cake and you can probably just scrap it and start from there. So in this case, I would add another column to have the sources And maybe I would have another column to have the question that was used to query the vector database specifically. I know you can do some extra magic there. So just like having those checkpoints along the way makes it really, really easy. This is all I wanted to talk about today. Thank you for joining. Thanks for watching. I'm really excited to dive into more ways to beef up your testing and your debugging, but this is a great first step. So don't forget, as always, to like, subscribe. I don't know what content is helpful to y'all if I don't get any feedback. So give me that fast feedback. It would be greatly appreciated. All right. Bye.